Hey, what's up guys? So today we're going to look at how to do the LeetCode max area of islands, the question 695 in Python. Okay, so given a non-empty 2D array grid of zeros and ones, and an island is a group of ones representing lands connected for directionally horizontal or vertical, you may assume four edges of the grid are surrounded by water. Find the maximum area of an island in the 2D array. If there's no island, the maximum area of is 0. So example 1, you have to return the maximum area of the island, and as you can see, the little like a bolded area here, 1 1 1 1 1, and this is and also this one, there are 6 ones, so it's the maximum area, so we output 6 because all the other islands, such as here, there are 5 islands, and here there are also 5 islands. Their area is still smaller than the 6, so we output the 6. And for this example, because there is no island at all, the maximum area of island is 0. Okay, and it seems to be a very popular question, and many company ask this question. So this question is actually very similar to the number of islands question on LeetCode. I believe number of islands is maybe the third question or the first few questions, and very popular questions. So basically, what we do here is that we traverse through the 2D grid, and whenever we see a 1, we trigger a helper function. The helper function can be a breadth-first search or a depth-first search. It doesn't really matter. What the helper function has to do is, first of all, count how many ones they are in the adjacent ones they are. And the second thing the helper function should do is mark the ones as 0. So for example, when it traverses to here, my helper function will return 1 as all the adjacent ones, and also mark this 1 as 0, so that I know I already traversed this place before. I won't go into it again. And for example, at here, it will trigger the helper function, breadth-first search or depth-first search, and the helper function will travel all the adjacent ones. So for this one, for this one, for this one, it will all traverse through them and mark them as zeros, and also count how many zeros I've encountered. And once I output 4 here, I mark all the ones as zeros so that the next time I won't go back to it again. And at here, the helper function will return 3, and here it will return 3, and here it will return 6. So I can maintain a global variable called maximum area, and every time my helper function got triggered, I only update my maximum area when the current maximum area is bigger than the previous is the biggest. So for example, here the maximum area is 1. Here the maximum area got updated to 4. Here it doesn't get updated, but it's because it's 3 and it's smaller than 4. And here the maximum area will be updated to 6. And at the end, we'll output 6. Okay, so let's look at the code. First, I have to know how many rows and how many columns are there. And these are my help function. So I will look at that later. So what I do, as I said before, is maintain a global variable called maximum area. and just traverse the 2D array. Whenever the grid ij is equal to 1, I trigger my helper function. Here I use DFS, but you can use BFS or like a recursive, whatever. It's just like, it's up to you. So my helper function will return the adjacent area, and I will make it current area. And my maximum area will be updated, will be the greater of the previous maximum area and the current max area. And all I need to do is to return the maximum area. Okay, so the most important thing for this question is how to write the helper function, because the helper function needs to mark all adjacent ones to 0 and also count how many ones they were, right? So how do I do that? Here I just use a stack. So DFS, we use a stack. And this is just like a template for DFS. So if you're not familiar with how to use stack to do the DFS, then probably you should watch more tutorials about how like a stack work for DFS and how the template code looks like. So basically you initialize a stack and you append the ij into the stack. So ij you pass in here. You append that and you initialize a set called seen or visited. And the count is count how many ones they were. So while stack, you pop the thing from the stack, so you get the current row and column index, and you append the current row and column into the visited or the seen set. And your count should be should increment by 1 because, for example, you visit here and you trigger the helper function and you pop this 1 from the stack, and you have to add one to the count because you are visiting a new node, right? And so you will also mark this one that you've just visited as 0 because you don't want to revisit it again. Okay, and this is just, again, the template for DFS. So because all we want to do what? We want to append the adjacent four directional adjacent cell, which are ones into the stack, right? So this is how I do the four directional adjacent. So I said for row offset, column offset in -1 0 1 0 0 -1 0 1. Basically, these are the offset of the adjacent two. So this is the left, right? This is the, this is the top, this is the bottom, this is the left, and this is the right. So my new row and new column, which is the adjacent cells indexes, are my current row plus row offset and the current column plus column offset. And basically what I'm doing here is that I'll get the adjacent cells indexed and I have to append them to my stack and also mark them as 0, right? So, but if they're out of the range of the